Let's look at an example of resonance gone bad. I don't know if everybody's heard of the Tacoma Narrows Bridge in Tacoma, Washington, but it is definitely an example of what happens when resonance begins to affect a structure. Now, this is a bridge. It was built in 1940, and it was known for pitching and moving during wind. And the designers had kind of taken shortcuts on the materials, and you can see how the bridge is just pitching. There's a sine wave. If you look on the edge there, you can see a sine wave in between the two supports. Now, it's interesting that this is a constant wind, so it's not actually a strict form of resonance that we've looked at, but it is still a form of resonance. It's called aeroelastic flutter. And so as the wind blew, it wound up the concrete and steel, and then once it got to a certain point, the concrete and steel snapped back, and then it went the other direction, and then the wind would pick it up and cause it to go in the opposite direction in the twisting motion. Now, this is concrete and steel. I know in 215 you had a lab asking about whether concrete is elastic. Don't know what you answered at that time, but looking at this video, you can see that concrete can be elastic under certain conditions. Now, after a certain amount of time, it's going to lose its ability to maintain that kind of elasticity, and it's going to break apart. Yes, there was a dog in the car, and unfortunately, the dog died. He actually bit the professor who was trying to save him, and he ended up not making it out. Now, the interesting thing, if you look down the center where the yellow line is, you can see that's fairly stable. So it's twisting around that section of the road as it's doing that torque. And you can see as the gentleman's trying to walk, he's trying to stay towards the yellow as best as he can, because that's the area that's moving the least as the bridge twists back and forth. And eventually the bridge will give out. Now, this collapse started a whole new branch of engineering where they would look at little models and see how those models reacted, and then they could come up with ways of designing precautions from collapses happening. Today we see demos of buildings, and they run fluids and air and all sorts of different conditions around these little models. This was the beginning of that kind of analysis. They had never seen this type of action occur, and they didn't know how to examine the failure. And so the engineer who was tasked to find what happened, what forces were involved, created a miniature of the bridge, and he started that whole science of miniaturization and testing. So this is a good example of resonance gone bad.